Okay, well, thanks for intro, and let's get started. And today we are going to talk about changing landscape of open source databases. And with questions, you can enter them in Q&A, and I will check that periodically. Unfortunately, it's not as easy in a virtual event to see questions as I would if you're all sitting in the same audience with me, and I can see if you itching to ask questions but not quite raising a hand yet. So we are going to talk about the changing landscape of open source databases through two sides. One is how the open source is changing, and the other is how the database technology has been changing recently. Now, what is open source or free and open source software? Now, you can actually see there multiple definitions in this case, right? And the two most common ones, they come from Free Software Foundation and Open Source Software Initiative, which you can check out if you need. One interesting story about or interesting thing about the open source software is it's actually much older than many of us recognize. Actually, in the very early days, when the software in the industry was just being born, the software was open source, though it didn't have the open source name at that time, right? The reason for that was the hardware and the software were bundled in the early day, and the source code was shipped at that early software. And it was very much expected for early adopters to modify the code and fix bugs and really add functionality which they needed. And then all the changes to such source code were shared according to academic principles of sharing knowledge, right? Just like you would expect with open source those days. Now, that lasted until 70s. And in 70s, there have been a number of developments which changed how we approach software development. One is IBM was subject to their antitrust lawsuit. And one of the things they did to sort of deflect that was to unbundle software and hardware. So instead of getting hardware like mainframe and software all together, you could just get a hardware and then software would be sold for you additionally. So some other software vendors could provide alternatives and compete. Another thing which is very important development at that time is what software became copyrightable item. It's maybe kind of hard to believe those days because so much IP is really software related those days. But before 70s, software was not a thing, right? So music, right, or literary work and a bunch of other stuff was copyrightable, right? But software was not on the list of that item, so you could not copyright, right? And once it became copyrightable items, multi-billion-dollar software industry was created, and the proprietary software became a major class of intellectual property. So if you look at 1980s and the 1990s, this was an era what I would call of romantic open source and free software. At that time, there have been a lot of people, and you can see here the picture of Richard Stallman, who is a kind of controversial figure of those days, but he was really very important folks in that era, kind of creating philosophy of open source software. And I call it romantic because people who would create open source software at that time were not doing that to get rich. We are often creating software for themselves, right? Or because just that was their passion. If you look at the next decade, 2000s, right? And that is approximately the time when I was myself starting to get involved seriously with open source software. We see really the rise of open source, and this kind of gets some really interesting developments. On one side, it really has critique from established companies in the marketplace, like Steve Ballmer, at that time CEO of Microsoft, famously calls Linux a cancer, right, or compares that to the cancer. And obviously, Microsoft went a long way those days in embracing and adopting open source, but I think that is interesting to see what their position was at that time. And we also had some of significant exits at that time. In early 2000s, Stan acquired MySQL for $1 billion. That looked like so huge money for open source business at that time, right? It is now. We have many companies in the open source space which are valued in 10 billion plus, right? But at that time, that was insane amount for open source software. Now, why those things are happening? Well, that was happening because businesses started to really understand the value of open source software. And businesses did not start adopting open source because of some philosophical merits, right? Or because it is, better, but because that came with a lower cost, short-term and long-term, and allowed them to be more competitive in the end, right? And open source software provides a lot in this regard. It offers you direct, lower cost, right? Because you don't have to pay for licenses in many cases. You can also see what engineers, especially smart ones, they prefer open source because they can really understand it better compared to proprietary software, which leads to better productivity, faster innovation, and also you can really avoid software vendor lock-in with open source software, which, as many businesses learned the hard way, over long term is extremely inconvenient and expensive. Another thing which is became reality for open source, and I think which is not many people in the US put a lot of emphasis on, but is the international realities, what I would call, right? Unlike proprietary software, open source software is much more so insulated from the politics, right? It's much harder to ban certain countries to use open source software, or it is much harder, for example, for your security services to build in something into that software, right? So they can really potentially spy on you, right, for benefits of their own countries. And these concerns are not a big problem if you think about folks in US, Canada, but as I travel to the countries and speak to people in places like China or Brazil or Russia, for many of them, this is an important aspect of adopting open source software and supporting software on open source software on a government level, right? For example, the biggest commercial bank in Russia, Sberbank, have moved most of their workloads from Oracle to Postgres. Not because they don't like Oracle. Well, frankly, Oracle was very convenient for them because of a fantastic industry of the kickbacks it created. And there is nobody to really give a huge kickbacks in PostgreSQL space. But because of all those sanctions and the complexity of relationship between United States and Russia, they chose open source software as a safer choice in this regard. Now, what also happened in this time and age is what we have a new generation of open source companies, which have started really as a businesses first, right? These have started by entrepreneurs who say, hey, this looks like it's a great market opportunity. Let us go ahead, raise money and we are going to change the world and provide high return to our stakeholders and fast, right? And unfortunately, this approach is not always compatible with original ethos and values of the open source, right? You would see those companies, of course, would use an attractive messaging of the open source, which, as we spoke, businesses appreciate, but they at the same time use the approaches which they learned in the business schools in terms of how to build a successful business, right? Which is, in a lot of cases, preventing people from competing with you, right? So they learned what we need to build monopoly, avoid commoditization, increase stickiness, build anti-competitive modes, and so on and so forth, stuff what you learn in the business school, right? Which is quite an opposite about, hey, how we can share things and build a better world, which I think the open source software is really about at large. And this really created a lot of not quite open source software, right? We can see business, we can see open core approaches, open source eventually, such as BSL license. We have shared source license like SSPL, like open source compatible software, and so on and so forth. Okay, let's see, I have a question. Okay. Okay, let's see. So I got a questions coming up, which I will answer so we can keep that a little bit more interactive and me just going through my narrative. The question I have is, do you think data is more secure in open source in recent time? Could you share any data points here? Well, I think security in open source, it has been kind of always a little bit kind of controversial, right? Because at large extent, the proprietary software allows you more of a security through obscurity, if you will, right? Because it's not as easy people to understand the code and so on and so forth, right? But if you look at the serious hackers, if you will, they are able to look at the at the proprietary source code and find holes in it. While the benefit of a real open source, which while does not guarantee security, is what it is available for review, auditing, and even hardening by community at large, right? I mean, recently you may heard about for SolarWinds hack, for example, not quite the database, right? But still, right? And some of the things which happen out there were quite obvious design issues, right? Which I would argue most likely would be spotted much faster if a software would be open source, right? In this case, before they were able to be exploited by some hackers, right, for significant period of time and at a large scale. Okay, so going back to our open source and not quite open source software. Now, the other thing what you would see is something called open source compatible software, which is, I think, great in terms of that is a very clear proprietary software which claims compatibility with some open source software. You just have to understand what that compatibility means. And typically that is what I would call limited Hotel California compatibility. That means such solutions are typically designed, making them easier to be adopted instead of proprietary, fully open source edition. But that is very hard to move back, right? Think about Amazon Aurora, right? For example, which has a whole bunch of extra features addition to what MySQL offers you. But if you start using them and they are really sexy, so it's hard to resist not to use them, then you are stuck with Amazon Aurora, right? And you are really not much less of a host than if you would be running proprietary database as it is Oracle. So how do I take that not quite open source development? I think that is great from one side because you can see a lot of investments and high pace of innovation, where a lot of that spills in the open source proper as well. But it's also bad because it doesn't really provide the full value of what true open source software is able to provide. And also sometimes it gets people to confuse the true open source, which is built according to their open source principles, with open source in a quotes, right? Then companies just use open source term for marketing. Let's look at the next decade, 2010s, and that is what I would call the rise of a cloud. And the cloud and open source is interesting because I think it brings interesting challenges and open source opportunities to open source software. But before that, let us talk a bit about this bait and switch on a switch of a cloud promise at all. This image, what you see here, is something what Amazon Web Services used to explain cloud to people when people did not understand cloud, right? Probably was by now like 20 years ago. And that was really compared to the electricity, right? An analogy makes sense. Well, it doesn't make sense for most of us to manufacture our own electricity, right? It's noisy, smelly, and expensive to run the generators, right? But well, it is connecting to a power utility is so cool. Well, and that really makes sense. But one thing about electricity is what electricity is commodity, right? Wherever you produce your own electricity, you buy it from provider, it is all comparable, and you can run your TV or your fridge, wherever you choose. Now the cloud providers, there's sort of pivoted and start to not just provide commodity services, but really things which lock you in, which would be akin to getting the fridge or TV, which only can work if you're buying electricity from a given electricity provider, right? Not so cool. Another thing what happened with the cloud is what before the cloud became commonplace, there was substantial amount of software using GPL license, which really prevented software being distributed and used for commercial case. You would have to distribute your changes as an open source if you are using GPL software. That is not the case with the cloud. For example, Amazon is able to, commercially use and make a lot of money on MySQL without having to pay anything to Oracle, right? Who is the main copyright holder. So it may be not surprise what you see, what a lot of licenses recently, a lot of the companies recently changed their license from fully open source license to what is called like source available license, often with some restrictions to be used by the clouds to resist the competition. Another interesting development what happened with the cloud is what while in 70s we have the hardware and software became unbundled, now they're bundled back together. If you're buying Google Spanner, Amazon Redshift, Aurora in the cloud, right? You're not really paying separately for hardware and a software. You are buying the single solution. And what that means for open source is there is no more zero price effect, right? If I want to run proprietary Amazon Aurora or do it yourself MySQL on EC2, in all cases, I would have to sort of, pay for an instance type, and it's just going to be slightly more expensive for Amazon Aurora, right? Compared just to EC2 instance. Compare that to software being absolutely free, right? Versus paying for that. The zero price effect, what it's called in psychology, is very powerful, right? There is a huge difference between paying something and not paying anything, right? Also, what we see in the cloud, what database as a service became the trend, how to deploy the database, and they tend to be much easier than do-it-yourself open source solutions, which is of course very seductive. Which comes us to the database as a service, which I think becomes prepared way to consume database software. Whether that is an open source or not, database as a service is a huge trend. And what that causes from the landscape change is that makes it much easier to adapt multiple database technologies. There, in the past, if you would want to run, for example, in FluxDB to store some data, you will have to get commitment from maybe your ops team to run it for you, to make sure it's secure, highly available, and so on and so forth. Now, you can just pay to the cloud vendor to get a managed in FluxDB instance, right, which can be a lot less friction. And that actually causes a lot more database variance is being adopted. One thing which happened with database as a service, as often happens, is what became over-marketed. So database as a service, they indeed provide a lot of very helpful benefits, but often it's not as complete as you would see. For example, you may have seen recently, in recent years, a lot of disclosures about the database security issues, right? Which often can be related to some very basic database security practices. Like, hey, I exposed my database to the whole internet to see a very basic password, right? Or I stored backups which were not encrypted and they were just stored on, public S3 or something like that, right? A lot of those are really connected with the developers, which do not often have a passion of database security, right? Are put in charge of running databases just using database as a service, right? And that is how mistakes can be easily made. Now, as we are using the cloud, you can see what there are two basic ways you can think about using the cloud. You can use cloud as a commodity, right? As I mentioned, compare that to electricity. And in this case, you use compute instance, right? And other APIs which are portable between the clouds, or you can use highly differentiated clouds, right? Use the most kind of cloud-specific features and software. And obviously, if you choose to use that highly differentiated cloud, you may get more simplicity, even more performance, but you would get in on the software giver, right, in on your flexibility and really have a lot of software lock-in. In my opinion, really, no one wants to be a hostage. And especially that is, I think, a case for larger enterprises who have been there before. They have played many decades ago, maybe IBM and a kind of hardware lock-in, and then with Oracle and other software vendors logging into software. And they want to avoid that. And that is why we see a lot of companies now using multiple open source databases, right? Among the multiple clouds, multi-cloud and hybrid cloud. And I believe at enterprise scale, that is a trend which is going to continue. Now, if you look for this trend, actually there are a number of solutions, both proprietary and not, available for this multi-cloud hybrid cloud. But there is also the emerging standard of a Kubernetes as an open source API for hybrid and public cloud. And in my opinion, if you are really understand the value of open source, that is something you should be looking at those days, and how to run databases and actually other database applications among the cloud. So what you think about the open source databases and what is happening or should happen? Many open source databases still need to adapt that kind of cloud native deployment in multi-cloud and hybrid cloud. Kubernetes API, right, and related solutions in open source database, such as operators or other ways, really becomes available more and more for open source databases. And I believe on the next iterations, we will get the simplicity, which is comparable to the integrated database as a service solution on Kubernetes, but obviously without the nasty vendor lock-in. If you look from Percona side, we are also working in this case. We now have operator software for MySQL and for MongoDB, as well as Percona monitoring and management has released the early version of database as a service functionality, which we are planning to launch sometime later this year, which can provide you something like GUI similar to Amazon RDS and API to deploy and manage your open source database in completely open source package. Okay, let's now shift from open source and talk about what specific developments are happening in the database technology. Now, if you think about database technology, I would split history in just these three big groups. If you look at the early days of databases, actually there was a lot of fragmentations, a lot of ideas in terms of different data models, query languages, and so on and so forth. But then in 1980s, 90s, we really see the dominance of relational database and SQL language, especially in the enterprise. Right, that what used to mean being the database. As we move to the internet year and 2000 plus, and especially in the cloud, where, as I can say, it became much easier to innovate with different database approaches. And also we have so massive amounts of data to manage and so massive amount of use cases, what there is a purpose-built case-specific databases became much more meaningful. Right, so we really have a new wave of innovation where we have a data models, query languages, and so on and so forth, right, where innovation happens. So if you think about the current trends, which I think we're worth to cover, is what we see is developers and architects are increasingly empowered to make database technology choices, right? So where a decade ago, you may say, hey, well, our DBAs decided what our technology is going to support those three database technologies. Now it's often, wait, developers, architects, what database technologies would you prefer to use to build the applications we need to be built here as a business as fast as possible? And then figure out where those will be maintained in-house, right, or maybe with a cloud provider. And as I mentioned already, cloud makes using multiple database technologies much easier than before. Another trend which is interesting is a microservices architecture, right? Why is that interesting? Because in this case, each microservice can use its own data store, right? Instead of just one monolith, which is connected to one huge database. And that also creates for much more variety even inside one single database in terms of what applications are being used. The next component is, I think, is a multi-store. We found now what the storage and even computing resources are relatively cheap. And what that means, it's not such a big deal to store data multiple times if you need it, if that makes it more efficient and convenient for you. So it's very common for folks to say, well, you know what, our data comes, let's say, to operational database, and then we push it to the Kafka, and through Kafka it moves to one database which we use for search, another database which we use the same data, maybe kind of in a different format for data, for analytical needs, and then it will go to another system where we will apply some machine learning algorithms, right? All of them will store essentially the same data, but in a purpose-built systems which help to solve particular problems better. Now, one discussion you can see going on right now is, well, should we use an SQL or NoSQL? Or you can also think about that as relational or non-relational. And there are folks who even kind of love SQL, how expressive it is and how much it allows, versus maybe some other developers say, oh my gosh, SQL is so damn complicated, and using some NoSQL database, which much more simple interface is great, right? And you can see, both camps are very successful right now with both open source SQL and NoSQL databases are growing. Here is, though, interesting stats from DB engines, which ranks different database engines by the different languages or interfaces. And you can see with relational databases, right, are really dominant at this point in time, right? Well more than 70%. Though you would see what the SQL database are not growing, or relational database as rapidly, if at all, compared to some other databases, right? If you think over last 24 months, right, the time series databases, I think one of the fastest growing trends, and that makes sense because if you think where internet is going with rise of devices, Internet of Things, we are really getting a lot of time series data from those data sources, which needs to be stored and processed very efficiently, for which relational database are not also always best suited for. The questions we may have about databases is, well, as we're seeing the new ideas and new trends, what are we going to do? Are we going to go and invent completely different data model, or are we going to extend the relational model? And actually, again, both those are happening at the same time. You can see SQL being extended, for example, to work with JSON data more conveniently, right? And there are some other different SQL extensions being proposed, right? Or you'll see solutions like TimescaleDB, right, which is a relational database, but has a storage seriously optimized for time series data, right? At the same time as solutions as Cassandra or MongoDB are also growing and very successful, while they are working kind of starting from scratch, right? Now, the other thing I think is interesting in this case is if we have a multiple use cases for our data, what are we going to use? Are we going to have like a single multimodal database or hybrid transaction analytical databases, or are we going to use a multi-store as a trend where we have multiple copies of data? And you can see again, both approaches are evolving at this point at the same time, and we don't know what is going to win, and maybe they will both work very well. On one extent, you can see technologies such as Amazon Aurora, right, or Oracle with MySQL in the cloud offering HeatWave, really optimizing for hybrid transaction analytical database use case. On the other hand, we see a lot of rates of technologies like Redshift or ClickHouse, which are purpose-built analytical databases. The next question I see people are kind of wondering right now is scale up or scale out, right? Well, and the question is not about where we need scale out, right? Because if you really look into massive applications, you cannot really have application built on one single database node. But the question is, do we need the database technologies which are really optimized for running on the single node and can run with a large environment, or should we just focus on their databases which are always run as kind of massively distributed database on the small node with a scale out? The jury for this is still out. If you think about the database as MySQL or MongoDB, they are really designed as a single node database, and scale out layer, also often referred as a sharding, is typically built on top of them. While you see other technologies, CockroachDB, Yugabyte, TiDB, Cassandra, which have been designed as a distributed database from the scratch, right? And you can see both of them have different use cases and growing. From my standpoint, I think if you are looking for large applications, you of course will need that kind of scale out. But with the power of modern computers, for many resources, just having single database, which is not kind of complicated massively distributed technology, maybe better choice. If you're running, WordPress, right, or some other simple company site, well, frankly, you are nowhere near the needs of a massive scale-out database. Finally, let me go quickly over architecture trends, which are happening right now, right? One is obviously building the locally distributed databases, which we discussed, and that's important for scale out. Another trend is what we are starting to get a database which also support with geographically distributed databases, which is driven by performance needs because speed of flight is limited, but also by government and compliance. For example, many governments require what the data of their citizens or residents are stored in their country, not in some other countries. And that means if you want to operate international kind of system, you may need to have a geographically distributed database. We see a lot of databases are really adapting or even having complete rights for cloud native implementations running in Kubernetes. Percona now operators for Kubernetes is no exceptions. We also see though some databases which are just bolted on and to a specific public cloud and only available out there. Amazon Aurora is only in Amazon. Google Spanner is only in Google. Microsoft also has Cosmos DB, which is available on Microsoft Cloud, cloud only. And as I mentioned, that is a great way for locking. Another interesting trend, what we see is a separation of storage and compute, especially in the cloud, where you can say, well, you know what, we actually want to store our data on something which is scalable and cheap, maybe such as the S3 storage. And then we want our compute layer to be scaled independently, right? Because scaling compute often can be done very fast, while scaling storage in a classical way, right, by adding more storage nodes, often means shifting a lot of data around, and that is fast. And the last trend I would mention is the hardware acceleration, which is also very interesting, right? And we see some databases either using GPUs or some database are being built even to use some purpose-built accelerators. We see a storage which is designed to offload some functions of a database to run on, like your NVMe storage card, which all allows us to really get even more efficient databases in the future. With that, I would say that there is a lot going on, and that's a really great time to be involved with open source databases, right? And I would also encourage you, with everything is going on in the open source space, is to really help your friends to understand the value of a true open source. And if you folks are interested to learn more about the database specifically, open source database specifically, not just open source, we would welcome you to also attend Percona Live online conference, which will be happening in May this year, and registration for that is free. With that, that's all I had for you today, and I think I have a time for a bit more questions.
Thank you, Peter. That was an interesting talk.
Yeah, let's see. I think there was some other question in the chat. Was it? Oh, that's you. It was you saying, "Hey, Peter, 5 minutes. Don't run over time."
You're right.
Okay,
folks. Awesome.
Yes. So, any questions first? Right. I think we got the PK's question on security address in the middle, and despite that, everybody else was so shy. Come on, folks. Anyone? Going once.
I have a quick question then.
Oh, you have? Okay, go for it.
It's really regarding as a company that you guys are trying to do. Where do you see your space? Maybe not competing with other big techs in open source in open source products, but is there a near-term goal that you would like to share with us?
For Percona? Well, I mean, if you look at if you look at Percona, right, we have our mission, right, the purpose, which is public, is keeping open source open, right? So if you are looking to really embrace open source for real, right, and look at and run top open source databases in a truly open source way, then we provide software and a solution to do that, right? And what I mean by that is, if you think about MySQL, right, for example, there is, of course, Oracle, who has MySQL Community and MySQL Enterprise with additional, often important for enterprise bells and whistles, right? And what we do at Percona, we provide our own solution, which has most of that kind of proprietary MySQL enterprise features, but in open source edition, right, and more. And we do the same for MongoDB and increasingly Postgres.
Okay, that makes sense. Yeah.
Okay, I see Troy just was saying thank you. Thank you, Troy, for attending.
Yeah, and thank you everyone for attending the first session for the Technology 2 track. The next session starts in 15 minutes, which means around 12:45. Yeah, let's thanks Peter again for the wonderful talk for the Technologies 2 track. And if you would like to connect with him, the links on the slide, his LinkedIn and his Twitter. I can continue asking him any questions in the open source space if you have. Thank you once again, everyone. Thank you, Peter, to be our first speaker for the today's session.
Okay, thank you for thank you for attending. Bye then.